Welcome to Pomodoro Joe for Wednesday, September 6th, 2023. Today we're doing LeetCode problem 725, split linked list in parts. This is a medium problem. So in this problem, we're given the head of a linked list and a number k. And we need to split our linked list into k linked list parts. And these parts all have to be as close to the same size as possible. If we can't make them all the same size, then the larger parts have to be at the beginning of our list of parts, and the smaller parts will be at the end of our list of parts. And at the very end, we need to return an array of the k parts. All right, so we're going to split our list into k smaller lists. Cool. We'll put 25 minutes on the Pomodoro timer, and we'll get started. Now, one thing it does say, let's see, I saw this somewhere in here. All right. We may end up with some parts being null. So if we don't have enough parts to make k parts, then we have to fill in the rest of our array with empty lists. Okay, so let's start out with our result here. Result equals some array, and we'll return the result at the end. Okay, let's talk about the math a little bit before we jump in here. So we'll need to know how many elements are in our linked list. Now, unlike an array, the linked list doesn't tell us how many elements it has in it. There's no length function for the linked list, other than us calculating it ourselves. So we'll have to traverse the entire list to find out how many nodes are in the list. Once we know how many nodes are in the list, then we can figure out how many nodes we need per segment. So let's have something here like node count. We don't know what this is yet, but once we know what it is, then we'll take that node count and we'll divide by k to find out how many nodes we need per segment. So I'll do a segment count. And our segment count will just be the node count. Do an integer divide by k. So for example, if k is 10 and our node count is 100, then we can say 100 divided by 10, we need 10 nodes per segment. Now what if we had 105? Then we'll still have 10 nodes per segment, but we'll have 5 extra nodes somewhere. So we'll need to put those 5 extra nodes in the first 5 segments. So let's have this extra nodes count, or segment extras, that's what I'll call it. Okay, so our segment extra, well, that's our node count modulo k. So this will tell us the remainder. After we've divided node count by k, what's left over? That's this modulo by k. So this segment extra tells us how many nodes we have left over that we'll need to add to our beginning segments. And then once we figure this out, we can just go through our list one more time. So we have to go through our list one time just to count the number of nodes. Then we have to go through the list a second time to basically divide it into the different segments. All right, so let's get started. I'm actually going to be a little bit lazy about this, and instead of going through my list twice, I'm actually just going to go through the list one time, and I'm going to throw every node into a list, into an array. Now, it's not going to be too intensive if we do that, just because these nodes are reference types, meaning I'm not copying the nodes to put them into the array. I'm just referencing the same nodes that are in the list. So I'm going to have a nodes list here. All right, and then I'll need my node. That's going to be head. And while we have a node, we're going to just put every node into our nodes list. Nodes.append, this node, and node equals node.next. All right, now we've gone through our entire list, and we've stored every node into our nodes array. At this point, the length of our nodes array is our node count. So let's actually move all of this stuff down below. All right, so this node count is the length of our nodes array. And then our segment count and extra count is just based on k and our node count. So we've already got those. Now we have to go through and actually divide up our nodes or our list into these segments. And since we have all of our segments or all of our nodes already in an array, we can actually just jump to an index to break our segments or break those links to make our segments. So let's see, I'll have some index. We're going to start at 0. And then while this index is less than the length of our node count, or actually we can just less than node count. Cool. So while the index is less than our node count, we'll just figure out where each segment is. We'll split our list at that segment boundary. We'll put the result into our results array, and we'll move on to the next segment and keep going until we run out of nodes. That's pretty straightforward. All right, so our segment start will just be at this index. And our segment end, let's see, well, that's going to be at this index plus our segment count. And then if we have any leftover, we might need to add one more node. So that's this segment extra. So if we have a segment extra, then we'll add one more node to this particular segment. All right, and then we have to decrement our segment extra. All right, now we have the bounds for our segment. We have the start index and we have the end index. Cool. Now, one thing with our end index, that's going to be the node that actually is, I guess, the start of the next. Let me rephrase that. So imagine we have a segment count of 1. So if we have a start at 0, our end will be 0 plus our segment count, so our end will be 1. So that end is actually the next start of the next segment. So we only have one node, which means the node at index 0. So our end being index 1, or being 1, means that we're actually at the start of the next segment. So we have to break that link between the previous node, so end minus 1 node, and the rest of the list. So let's do that here. All right, we've broken that link. Now I'm okay doing this because I've actually got a reference of every single one of my nodes in the list, so I'm not losing anything here. All right. Next, we need to add this particular segment to our result. So the result.append, and that's just going to be this node at our start index. Cool. So now we've added that segment and we can move on to the next segment. So our index then becomes end. That's the start of the next segment. All right, now we've gone through, we've basically broken our list into our segments. We put each segment into our result, but we still might not have enough segments. They did note here, this may lead to some parts being null. So we definitely have to make sure that we've filled in our result to have at least k entries, or exactly k entries. So while the length of our result is less than k, we need to add a none. So result.append none, just an empty list, just to fill in the rest of our result. Okay, and I think this should do it. Not very elegant, has a little bit more memory overhead than if we went through our list twice, but I don't know, it might give us a little bit of a speed boost. We'll find out. Let's see how this goes. Seems to work. Let's see if we can pass all the tests. And we pass. Let's see, how do we do? We do okay. We beat 80% for runtime and 57% for memory, so not too bad. Now, this is sort of the lazy way of doing it. I didn't want to actually have to go through my list twice and start counting nodes. I just threw everything into an array and I used indexes just to jump into that array and split into segments. Now, you could do this without using this array. You could do the count first, then you could traverse the list a second time, keeping track of your current node or your current node index, just sort of counting yourself, and then you can split the list, add it to the result, and move on. So you could definitely do this without using this array. I was just being lazy. All right, that's a challenge for you. See if you can do this one without using the helper array. Just traverse the list twice and see if you can split it into segments. All right, well, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.